Okay. Number 7 says what? What does it say? We want to find the error of this, the error bound on this less than 0.08, right, of cosine. So similar to one that we did before. Okay, so cosine of x is approximately 1 minus x squared over 2 plus x to the 4th over 4. And we want the error to be less than 0.08. Right? Okay. Okay, so again, what I'm going to do is I'm going to write out the extra terms, because remember, how do we find the error? It's Rn of x, okay, is equal to, or is less than or equal to m. We'll get what m is in a minute. Okay, of n plus 1 factorial x minus a to the n plus 1 power. Right, it's less than the next term. Okay, the error is less than the next term, where m is the nth derivative of, or the n plus 1th derivative, sorry. I should probably just put what n is here in error. Let's just do f of n plus 1 derivative of x. Okay, but that's really what m is anyway. Okay, but it's less than or equal to this thing here. Okay. Okay, and we want this to be less than 0.08, right? We want that to be less than 0.08. Okay, so again, I'm going to take, what would be the next, how far would I have to go out with these terms, right? How far would I have to go out with these terms? So I'm getting less than 0.08, okay, with my error. Okay, what would x have to be, right? What would the boundaries on x have to be in this case, right? So I believe that's the question. Let me pull up the question real quick here. Why do I not have Acrobat on this one? I revamped my whole system yesterday, or over the weekend. So I did get my new computer, so yay. Now I can run off of 2 systems simultaneously. Can you mute yourself if you're not muted? Or I could try to do that here. Mute all. There we go. Okay, so let me pull up Adobe right here. Do I not have Adobe on this one? Is that what happened? Well, I'm just going to share my screen then on this one. I'll have to make a note to myself to download Adobe on my other machine. Okay. Okay, so we want chapters 11 exam review, right? Okay. Chapter 11 exam review. My computer, browse. Let me pull this one up here real quick. 90. Exam review, chapter 11. Okay, so what does 7 say, real quick? Use Taylor's inequality to estimate the range of values. Okay, yeah, for which x, for which of x for which the given approximation is accurate to within the stated area. There we go. Okay, this one is within. So what range of x, right? A such that A, yeah. Okay, perfect. Yeah, so that's exactly what we're trying to do here. Okay, so we want to find out for what value of x is this thing. Well, if we look at this, we know that A, okay, this is the Maclaurin series, cosine x is approximately, okay, so this is going to be, how can I say this? This is going to be x to the 0 power over 0 factorial, x to the 0 power over 0 factorial. Right, that's what 1 is. Okay, plus 0 x to the first over 1 factorial minus x squared over 2 factorial. Okay, and this is 4 factorial, I'm sorry. Okay, 2 factorial, 4 factorial. Yeah. Those should be factorials. Okay. Okay, plus 0x cubed over 3 factorial plus x to the 4th over 4 factorial plus 0 x to the 5th over 5 factorial minus, which goes minus plus minus. So the next term here in the series here is minus x to the 6th over 6 factorial. Okay, so just keep in mind that it's a minus there. That's the next term in the series. But we have to think of this as, you know, what is the term number that we're going up to in order to use r sub n of x. So this is going to be minus x to the 6th over 6 factorial. Okay. So if this is n equals 0, n equals 1, n equals 2, n equals 3, n equals 4, n equals 5, and n equals 6, we want to use this term. We do not want to use n equals 5 because it has a 0 as the derivative, and we just don't want to use it. We don't want to use that. So this 6 here is going to be our n plus 1th term, which means our nth term for our remainder has to be 5. Okay, so it's got to be 5 there. Okay, so our nth plus 1th term, we would go out to the 5th term, which is the 0, and then we would go out to the 6th term. Okay, that would be our n plus 1th term. So our nth term is 5. So n is 5, and our n plus 1 is 6. Okay, so then this is going to be less than or equal to the derivative of the n plus 1th term. We already know what that is because we know what the n plus 1 term looks like. It's negative x to the 6th power over 6 factorial, right? So this is, okay, so this is, however, there should be an absolute value here because we're comparing that to m, okay? There should be an absolute value. So what it is it's the absolute value of negative 1 all over 6 factorial times x to the 6th power. Okay, and that has an absolute value as well. okay, absolute value of x to the 6th power, and that has to be less than 0.08, right? So this is just going to be absolute value of x to the 6th power, which is just x to the 6, because anything to an even power is positive, right? The absolute value of -1 is just -1, okay? And where did I get the -1 from? It's right here. That's the negative sign there in the 6th term of the sequence here, of the series, okay? All over 6 factorial is less than or equal to 0.08. Okay, 6 factorial is what, 720? Okay, so we can multiply 0.08 by 720 and then take the 6th root of it. So the 6th root of 0.08 times 6 factorial and x, and there's an absolute value here, sorry. Okay, let's just keep the absolute value, yeah. Okay, because we want to get a boundary, top and bottom. Okay, so x is less than or equal to about, this comes out to be about 1.965. So I would say that a in this case is 1.965, or negative 1.965 is less than or equal to x, which is less than or equal to 1.965. Okay, so within this boundary, you would get a maximum error of 0.08. Okay. Within that boundary there. Okay, so you can go all the way up to 1.965. You could go all the way down to negative 1.965 in that range. At x equals 0, you're gonna have your maximum error there. Okay. Okay. Is that good? And any questions on that? Are we good on that? Okay. I got, oh, you got 9. Okay, silly mistake. Okay, perfect. Yeah, that one should be a fairly easy one. It's just 2n over n plus 4 squared. Is the 1 from assuming the max value of sine cosine? No, the 1 is coming from the derivative, the 6th derivative. So f to the 6th of n of cosine of x. The 6th derivative of this is negative cosine of x. So you do the 6th derivative, but then you just have to evaluate at 0, right? Because everything is evaluated at 0 for the Taylor polynomial. It's evaluated at a, and so that becomes -1, and then you just absolute value that, and that equals 1. Does that make sense, Susan? Oh, you need to read the question again? Okay. Okay, because again, it comes to us from the fact that we're finding the remainder here using Taylor's remainder theorem. So just look at this basically is Taylor's remainder theorem right here at the very top. Okay, so right here. Oh, I'm not sure how you would know a is 0. Okay, so do you see how in cosine of x here, we've got a 1 and then an x squared and then an x to the 4th, and so we're not subtracting anything from x. So if it was a polynomial, not a Maclaurin, you would get an x minus 3 squared. Right? Does that make sense? Over 2 factorial, right? So if that was a Taylor polynomial, it would be centered around 3. Well, the question says Taylor Taylor, it's not a Taylor polynomial, it's a Maclaurin polynomial. Now keep in mind, all Maclaurins are Taylors. They're just around 0. Right? But it's the Taylor what is it, error remainder theorem? I forget what they're asking here. What are they asking? Taylor. So there's a exactly. Yes. Okay. So the question says Taylor, but it's not a Taylor polynomial. It is a Taylor polynomial. It's because Maclaurin is a special type of Taylor polynomial, but it is a it's using the Taylor. I forget what it's called. Let me look it up right here real quick. It's using the Taylor. I'm never gonna forget it now that I. Come on. Taylor's inequality. It's called Taylor's inequality. Okay, that's what it's called. Taylor's inequality for finding maximum error. Okay. Yeah, exactly. That's A equals 0. Yes, perfect. On question 3, can you just go over which test should be used? Absolutely. Okay. On question 3, use the integral test. Okay, integral test. And if you want me to do that integral, I can. Because it's not a hard integral. It's just notice that we have a natural log. I'm going to pull this up real quick. I don't know. It's kind of annoying me that I can't pull this up. This is a PDF. I would like to see you work the integral, please. Yes. Okay, sure. Absolutely. Okay. So let me let me work the integral on number 3 here. I can't believe I was such a moron as to. I'm going to try to see if I can download this thing while we're working on the other. I didn't put in my Adobe's. So where do I want to go? I want to go here. Adobe. Passcode. Okay, perfect. Okay, that's going to take a long time. That's okay. Okay. So let's go back here. Share my screen. And share. Okay, so we're back. Okay, so number 3. Okay. Okay, number 3. I mean, it's not a horrible integral, but it's good enough. Okay, so we want the summation k equals 5 to infinity, and we want to know if this thing converges or diverges, right? Does this thing converge or diverge? Okay, so 5 over okay, 5 over k, natural log k to the 7th power. So k x is that a k? Yeah, natural log k. Yeah. Here we go. Okay, k times natural log k to the 7th power. So we want to know, okay, is this thing gonna converge or diverge? So if I change this to an integration, this is going to be 5 to infinity of 5 over x times natural log x to the 7th power, right? So notice that if I do a u du here on this, I have, there's a dx here. I have natural log of x, and then I have 1 over x dx. So notice that I have, an x in the denominator and my natural log. So it really is just a simple u du substitution on this one. Okay, so let's see if this thing converges or diverges. Okay, using the integral test. Okay, so let's integrate this guy. So this is going to be 5 over u to the 7th. Okay. And then I'm gonna go u of infinity and then u of 5. It really doesn't matter. I'm not gonna go back to x's anyway in the end, because they're just gonna be easier to work with. Okay, so and then this is, yeah, that's it, right? Okay, so oh no, this is, okay, we haven't integrated it yet. This is du. Okay, so this is u5, u infinity. Okay, and so we're going to integrate this thing. This is u to the negative 7th. So this is 5u to the negative 7th. So we're going to go up a power to negative 6 and then divide by negative 6. So this is going to become negative 5/6. So negative 5/6 u to the negative 6 evaluated for u of 5 and u of infinity. Okay, nice. Okay, so now I'm going to just plug back into x. Okay, so this is negative 5/6 over the natural log of x to the 6th power. What the heck? Screen sharing stopped. Okay. Interesting. Let's go back to the screen sharing. I must have hit a button. Wrong button. Okay. So we've got this guy, and then that's still going to go from 5 to infinity for our x's, right? Because we're keeping our x's. Okay, so how do we evaluate this? Well, this is going to be the limit, right? The limit as t goes to infinity, right? So we could think of this as the limit as t goes to infinity of negative 5/6 times natural log of t to the 6th power minus negative 5, 6 times the natural log of 5 to the 6th power, right? Okay, so, well, what happens when natural log of t goes to infinity? Well, it still goes to infinity, because think about what the natural log looks like. It looks like this, right? So as t goes to infinity, the natural log goes to infinity, and we have 1 over that. So this thing is going to go to 0, right? That thing goes to 0. And so then we're just left with a plus, okay, a plus 5 over 6 natural log 5 to the 6th power. That's what this thing's going to go to, which is a whole number. It's not a whole number. It's a real number. That's what I should say. Okay, it's a real number, and so it does converge. So this thing converges. The integration converges to this. Okay, the integration converges to this guy. The integral converges to this. And so since we know the integral converged, then what do we know about the original series? Okay, well, we know that then the original series converges as well. So since, we'll say since the integral of 5 to infinity of 5 over x times natural log x to the 7th power converges, and it converges to this 5 over 6 natural log 5 to the 6th. Since it converges, then the original summation, k equals 5 to infinity of 5 over k natural log k to the 7th power, also converges. Okay. So convergent. Okay. Okay, does that make sense? So far, so good. It's good. Thank you. Yeah, sure, absolutely. And others of these you want to see done? Number 4, okay, number 4. Okay, so we want to know, is this thing converge or diverge? Okay, so summation n equals 2 to infinity of negative 1 to the nth power n over 5 natural log n, right? N over 5 natural log n. Okay, so I can tell you right now this thing's going to diverge, but you probably wouldn't know that just looking at it. Because I can tell you right now that the terms are going to get bigger. Why do you think the term? Well, how can I look at this right here and see that the terms are going to go bigger? Any ideas? How do I know that the terms are not decreasing? Because n is greater than natural log n. Yeah, exactly. If we looked at if we graphed, you know, n, right? N versus, you know, what's y equals n, right? If this was n and this was y, right? Wouldn't that be a straight line, 45-degree line, right? And so that's going to go up a lot faster than this guy here, right? Natural log. So which one beats out which? Doesn't the y, it's basically y equals x. Doesn't the y equals x beat out the natural log? So if the thing on the top is getting bigger and the thing on the bottom faster than the thing on the bottom, then the thing on the top wins. Does that make sense? So it kind of beats it out. Now let's prove that. Let's prove that, because this thing is just going to fail the alternating series test, right? It's going to fail because of the second factor here, that that basically we need to know that the nth term is going to 0. Okay, does the nth term test work here? Well, no, it's not going to go to 0. It's going to diverge. This thing is going to diverge. Okay, I keep adding bigger and bigger terms. The thing's not going to converge to anything. So let's do the nth term test. Limit as n goes to infinity of n over 5 natural log n. Okay. Well, let's use Mr. L'Hopital on this one. Okay, so limit as n goes to infinity of 1 over 5 over n, okay, which is equal to the limit as n goes to infinity of n over 5. Well, that's just going to go to infinity. So this diverges. This diverges by the nth term test. Okay, diverges by the nth term test. Okay, or the divergence test. This book, I learned it as nth term test. This book says divergence test. So I apologize if I get, if I'm not following what the book, you know, we kind of always default back to what we initially learned. And to me, nth term test makes more sense, but who knows? Divergence test could make more sense to someone else because they're like, oh, well, it's just a test for divergence. It's not a test for convergence. So either way. Okay, on number 10, would we use the nth term test or a different test? Let's see, on number 10, would we use the nth term test or a different test? For number 10, you're gonna use the fact that you can split it up into a geometric. Let me just, so if it converges, then we have to use another test. I've been a bit confused on the nth term test. If it converges, then you have, yeah, well, yeah, because it doesn't tell you that it converges. It can only tell you that it diverges, Victor. Right? Think of the harmonic here real quick. Okay, think of the harmonic. 1 over n. Does that thing converge? No. It doesn't converge. But does it satisfy the nth term test? Yes. Okay. So just because the terms are decreasing doesn't mean that they're decreasing fast enough. Does that make sense? Yeah, but if they're increasing, then we're done. Then, I mean, that's the best case scenario when you're on a test is you're like, oh, the terms increase, I'm done. Boom, no more tests, right? You're like, oh, that's cool. But if they decrease, then yeah, then we have to go to another test. And we have to say, okay, does it converge? Does it actually converge? So, okay, number 10. Let's look at number 10 real quick. Ooh, make Adobe your default application. Yes. Do not show me this information again. Yes. Okay, how do you want to open PDFs from now on? Adobe. Thank you. Okay. Where's my computer there? Aren't any files here and here? Of course there's not, because we need to browse them. Browsing. Just be seen. Camera uploads, Cerritos. exam review. Come on, exam review. Give me my exam review. Dang it. Okay. Okay, so number 10. Okay, determine whether the series converges or diverges. If it converges, find its sum. Okay, so again, we're gonna take this and we're gonna, okay, we're gonna take this thing. I don't want to write on this. I don't want to save it. Come on, erase. We're gonna take this thing and we're gonna just divide it into two different separate sums, and then we're gonna use the fact that it's geometric. Okay, to find the sum. Okay, so let's do that. Okay, so we have the sum n equals 0 to infinity of 9 to the nth over 12 to the nth plus the sum n equals 0 to infinity of 8 to the nth over 12 to the nth. Okay. So this is going to become 2/3 to the nth, okay? And this is going to become 3/4 to the nth, right? 2/3, 3/4, no, is it the other way around? It's the other way around. I'm not good with my fractions today, I guess. Okay, 2/3 to the nth power. Okay, so summation n equals 0 to infinity. Now we know this is geometric. N equals 0, okay, right? So starting at 0, if n was 0, this thing would be 1. So a sub 1 is 1 on both of these. Okay, the radius of convergence for the first one, okay, r is equal to 3/4 on the first one, and then for the second one, r is equal to 2/3. Okay, so we know that the sum is equal to a1 over 1 minus r, a1 over 1 minus r. Okay, so this is going to be 1 over 1 minus 3/4, which is 1/4. So this thing is 4. Okay, this thing is going to be 1 over 1 minus 2/3, okay, which is 1/3. So flip that upside down, that becomes 3. So 4 plus 3 is equal to 7. So that's what that thing converges. It does converge because it's geometric, and it converges to 7. Okay, let me go blow my nose real quick. I got my flu shot today. I think it's making my nose run. Who knows? On number 11, I did the ratio test. Is there another test that could be used as well? Number 11, you did the ratio test. Yeah, you could do the alternating series test, right? Well, to me, that would be the easiest. But I mean, ratio tests will work too, I believe. Okay. But you know, I would try alternating series first before you jump into ratio. because we could do n equals 1 to infinity of -1 to the nth, n over 2 to the nth, right? So this is an alternating series, right? Now, which one of these is going to beat out? What does this thing converge? Can you look at this and see that it converges? Which one's going to grow faster, the n or the 2 to the nth? This thing's going to converge, right? How do I know that it's going to converge, right? Because n over 2 to the nth decreases, it gets smaller, and this thing goes to 0. Okay, does that make sense? You should almost be able to look at one of these and say, hey, you know what? Boom, this thing decreases, so we're good there. And the limit of this thing goes to 0. We're good there. Boom, we're done. By the alternating series test, converges. That's how fast the alternating series test is. You're just like, boom, does it decrease? Yeah. Does it go to 0? Yeah. Boom, done. Does that make sense, Victor? It's that easy. Okay, keep in mind that if you haven't started working on these yet, okay, I'll have an extra session of cramming right before the exam from 1:30 to 2:30 tomorrow. Okay, so I would highly encourage you to work through these, find the ones that you're not strong in tonight, and then come to my cram session from 1:30 to 2:30 tomorrow. Okay, AKA office hour. So I don't want to sit here and do all the work for you because, you know, it doesn't work like that. It doesn't work as good. Martin says, have I done number 6? I have not done number 6. Did you try number 6, Martin? Can you post this review session after we finish, please? Absolutely. I will do that. I got my new computer, which is 4 times as fast as my old one. I clocked it. So. Okay, yeah, I couldn't get it though. Okay, cool. Okay, like I said, as long as you try these things, I have no problem going through them. It's when students just don't even try and they're like, oh, show me how to do this. That's not going to help you at all. Okay, you need to struggle through these first. Okay, so we'll do 6 and 14. Let me get my water real quick, 1 second. Okay. Okay, let's go over number 6 real quick. Okay, what did 6 say here? It says use the binomial series to expand the function as a power series. Find the radius of convergence. Oh, okay. Well, we should know what the binomial expansion is, right? We went over that. So let's do that. Okay. Okay, so 1 over 4 plus x to the 5th. Find the radius of use the binomial series. Okay, cool. Okay, 1 over 4 plus x to the 5th. Okay, so 1 over 4 plus x to the 5th power. Okay, what's that going to be equal to? That's going to be equal to the sum, right? The sum. Well, let's look at it this way. this is going to be the 1 over 1 plus x to the kth power is equal to the sum n equals 0. We derived this in class. N equals 0 to infinity of kn x sub n. And this kn is, you know, out of k choose n items, right? Okay, so what do we got here? Well, what we have is we got to make this thing look like this. So we have 1 over 4 plus x to the 5th power, right? So what I'm going to do is I'm going to divide both top and bottom by 4 to the 5th power. Okay, so I'm going to divide both top and bottom by 4 to the 5th power, I think. I don't know. Well, let's think about this for a second. I'm going to divide, divide by 4 to the 5th power, yes. So divide the top by 4 to the 5th power and divide the bottom by 4 to the 5th power. Okay, so why would I do that? Well, this becomes 1 over 4 to the 5th power is 1024. Okay, and then this thing I can bring inside now, and this becomes 4 over, this becomes, 4 plus x over 4 all to the 5th power, right? Okay, which is equal to 1 over 1024 times 1 plus x over 4 to the 5th power. And we're going to say let u equal x over 4. Okay, so that's the deal there. Okay, because now I can say that this is equal to 1 over 1024 times 1 plus u to the 5th power. And that's very, very similar to what we had before. So now, given that, okay, we can say this is equal to the sum as n equals 0 to infinity of, okay, of out of k, out of 5, k choose n, right? Out of 5 choose n, x to the nth. But I have this 1 over 204. This is u, by the way. U to the nth. Okay. So this is going to be 1 over 1024. Right? So out of 5 choose n there. Okay, then equals 0 to infinity. Okay. That's right. Okay. Summation. Oh, you know what? This is not 5. This is negative 5. My bad. This is to the negative 5th power. Is that right? Yeah, because this is a negative k. So this really is 1 plus x to the negative k power, right? So, which is really, okay, this thing here was if k was positive, but k is negative here. I just have to take into account that this thing is a negative 5. This is now negative k. Choose n. Okay? Just keep that in mind. A negative k. So that's where we're getting, it should be a negative 5. Okay, negative 5. Okay, choose n. Okay. And then what's u? this is going to be u to the nth power, right? U to the nth power. Okay, u to the nth power. Okay, but then what is u? Well, u was, this is 1 over 2/4 times the sum, n equals 0 to infinity, of -5 choose n, x over 4 to the nth power. Okay, so that's my final result. Okay. I could figure out what subsequent terms on this are if I really wanted to. Again, you know, if I plugged in 0, I would get 1 here and I would get 1 here. So my first term would be, I could pull the 1024 out in front, and I could go 1, and then out of let's see, how many ways can you choose -5 out of 1? So yeah, you could plug that into a calculator if you really wanted to. However, it would be -5 factorial over -5 minus you know, n factorial and then n factorial, and you could figure all that out. Okay, or you can just plug it into a calculator. But this is going to give you -5, okay, plus -5 times, okay, times x to the x over 4, because that's just to the first power, right? And then the next one is going to be +15 over 16, because this is going to be x. It'll just be +15 times x over 4 squared. Okay, confirming that the instructions expand as a power series meant write it in summation notation. Yes, either way, you can do it either way, honestly. Yeah. So yeah, either way. Okay. So I'm just kind of showing you both ways here. So this is going to be 1 minus, this is 1 over 1024 minus 5x over 4 plus 15x over 16. Okay, and then it's going to go to a minus again, minus. It's just going to alternate because of that negative sign. Okay. Okay, and then just a dot, dot, dot here. Okay, what's the radius of convergence? Well, u, absolute value of u is less than 1. But what was u in this case? U is x over 4 is less than 1. So we know that the absolute value of x is less than 4, which means that the radius of convergence is 4. R equals 4. What was the next one, Victor? $14. Okay, 14. And what did you want to know on 14? Just how to do it or what? Oh, how to factor the right way? Oh, okay. Are you doing ratio test on this one? Yes, okay, perfect. Okay, yeah, let's do number 14. Okay, let me make sure that I write really neatly because there are a lot of factors here. Okay, so we want to know summation n equals 1 to infinity, okay, of n factorial to the fourth power over 7n factorial. And we want to know, does this thing converge or diverge or what? Okay. So we're going to do the ratio test on this one. Okay, so we want the limit as n goes to infinity of n plus 1 factorial to the fourth power over 7 times n plus 1 factorial all over all over n factorial to the fourth power over 7n factorial, right? So this is going to be the limit as n goes to infinity of, I'm going to get n plus 1 factorial to the fourth over n factorial to the fourth times, this is going to be 7n factorial over, and I'm going to distribute, this is 7n plus 7 factorial, okay, absolute value. Okay, so this is the limit as n goes to infinity of n plus 1 factorial over n factorial to the fourth power times 7n factorial, and then over 7n plus 7, I'm just going to write that out as 7n factorial over 7n plus 7 factorial. Okay, 7n plus 7 factorial. Okay. Okay, let's deal with the first one here. Okay, so this thing is going to be equal to, this is going to be n plus 1 times n minus 1, dot, 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 2, 1, and all over n times n minus 1, dot, 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 2, 1. Okay, all of that raised to the fourth power. So this thing is going to get canceled.
Do you have any cash on you?
Yeah, why?
I just want like some money because I want to get something at the vending machine, and I did your dishes. So.
Oh, I only have a $20 bill.
You only have a $20 bill? I mean, can I have the $20 bill?
Huh?
Okay.
Are you done with the dishes?
Yeah, so they're all done.
Did you run it?
I'll put it all in right now.
Excuse-moi, I had to give my teenager some money. Imagine that, right? Okay. So this becomes n plus 1 to the fourth power. Okay. Limit, right, as n goes to infinity. Okay, and then this is going to be 7n. Okay, so this one is probably the one that you're like, well, how do you factor this thing? Well, here's what we do, is we say, well, this thing is really 7n, right? 7n, okay, times 7n minus 1 times 7n minus 2 times 7n minus 3, dot, 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 right? Okay, all the way to 1. All the way over, okay, this thing, which is 7n plus 7, 7n plus 6, okay, dot, 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 all the way to 7n plus 1, 7n times 7n minus 1, dot, 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 all the way to 1. So we can see what's going to cancel out here is everything on the top is going to cancel. And that's going to leave me, okay, so I'm going to rewrite this, okay, as the limit as n goes to infinity of n plus 1 to n plus times n plus 1 times n plus 1 times n plus 1 all over 7n plus 7 times 7n plus 7 times 7n plus 6, I'm sorry, 6, 7n plus 5, 7n plus 4, 7n plus 3, 7n plus 2, all the way to 7n plus 1. Okay. Okay. Okay, and so let's see what we get here. Okay, let's just look at the first terms of these. This is going to be n to the 4th. This is going to be 7 to the, how many terms do you have? 1, 2, 3, 4, 5, 6, 7. 7 to the 7th over n to the 7th. Okay, plus dot, 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 plus dot, 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 right? So what's this going to go to? Well, what's going to beat out what? Well, the end of the 7th is going to beat out the end of the 4th, right? Okay, if I keep doing L'Hopital's rule on this thing will go to 1. And then this thing will eventually go to like an end of the 3rd, right? Keep doing L'Hopital's rule. Okay, and so since this thing is bigger on the bottom, this thing goes to 0. Okay, the limit. And the limit as n goes to infinity goes to 0, therefore the thing converges. Okay, because this is less than 1, 0 is less than 1, right? For the ratio test. So by the ratio test, it is convergent. Okay, makes sense? Perfect. Okay, you factored it weird, but it still looked similar. Okay, that's cool. Yeah. Okay, so once again, I would encourage you guys to try these tonight and then meet me in my office hours tomorrow for an hour before the test, if you haven't tried these already. Okay. You're very welcome. Yeah, I will be posting this, the review of the problems that we went over today as soon as the session ends. I'll be posting that on YouTube. Okay. Keep in mind that all Chapter 11 sessions are also on YouTube, so you can review those ad nauseum as well. Okay, I will, if there's no more pertinent questions, I will see you guys tomorrow at my office hour at 1:30. Okay.